house a little bit with something just to spread a little joy around here. All right, so welcome back. Let's go through let's go through the COVID update for today. Different backdrop here for Mr. Brown. I moved over the weekend, so nice pink room I'm in. My Zoom room for now, I'm calling it. So this is my little Zoom room until, you'll probably see the transition throughout the duration of the year, but this isn't a high priority for us to do. So, all right, let's start off with attendance. Please check the attendance. Kim, I'm looking for you, Kim. If you're here, just let me know. May have made a mistake. Cool. Does anybody have anything they want to share with their classmates? This is your time to take over the mic.
What are you doing for Christmas this year? Oh my God, that's my phone.
Your
What are you
phone's going
doing?
off. How do you know I celebrate Christmas though?
This year? Because of COVID and stuff.
How do you know I'm celebrating Christmas though? I might celebrate Hanukkah or something else. I don't like saying Christmas because I know everybody doesn't celebrate Christmas. I am celebrating Christmas. We really don't know. We're just going crazy over here. And
okay, well, how are you celebrating the holidays?
oh, thank you.
Yeah, like that. Like, how are you celebrating the holidays?
Probably on the DL, on low key a little bit, because we just moved into the house. So, and I don't know. We know a lot of people have COVID now, so we're trying to protect our little ones. So, I don't know. How about you, Micaiah?
We usually have like everybody at my house for like Christmas Eve and stuff, but now my mom's like freaking out and stuff, so
don't know what to do.
Not many people are coming, and I think like we have to wear a mask if like when people come. So
yeah, a lot of like out towners or
we haven't had like any like crazy like COVID scares because like we don't really like go anywhere.
Yeah, I know. I'll see either, but you never know. Doesn't take much. My neighbors at my old house, we just talked to them the other day, but they're like 80 years old and they never go anywhere. Nice neighbors, and they got COVID for just by going shopping. So
yeah, it's like so scary. Like my mom she's just going like right now to go pick up groceries because she does like online now because she's too scared to go in like the store.
That's a nice feature. I gotta try it out, that online order or whatever. The delivery service sounds cool, but I haven't utilized that. Anybody have anything else you want to talk about? Open mic. Mr. Brown, chemistry, open mic night.
I got braces on yesterday, and my mouth really hurts. Yeah.
Wait till, man, that tightening of the braces. I'm sure that's going to be a nice investment for you, though.
Faith, I just got mine tightened. They hurt so bad.
This is the worst.
It's so painful.
Does it hurt the first time we put them on, or the second tightening or first tightening? What's worse?
When I first got mine on, I had like a big gap, so it only hurt because like it was just closing it. Yeah. But now, like after they tighten, they just put like a bigger wire, and it just hurts so much more now because like they're trying to get rid of all my spaces, and it hurts.
Yeah, it's pulling them together. Jordan, I haven't watched any sports in like a month. I don't know. I just have been so busy. How about you, Jordan? You watch anything? I like the Giants. Go Giants. I haven't watched them. Even though like they're top of the division and they're kicking butt, I haven't watched them, but cool. All right. And anybody anything else? Hopefully you guys are all safe. Let's check out the COVID update for today. Share my screen again. I was hoping if I like took the share screen off, you guys would like pop on. It'd be like everybody in class like sitting at their desk. But no one put their camera on, so that's okay. No big deal. I don't really expect you to. You guys don't want to show off your house and your nice pajamas. Maybe you do. Now I don't know how to share my screen. After I did that, I'll have to figure it out. Oh, here it is. Okay. All right, so here we go. Let's check out the COVID update for today, the weekend, the past few days. Here's the Oneida County dashboard. This is data that Vicente and his team put together. There's a curve, long curve analyzing. Beginning of the year, we analyzed some charts and curves. So Definitely relatable. The Cowboy Joe. I think the Cowboy always stink, don't they? Just kidding, Joe. That's your team, I'm guessing. All right, so the COVID update. Here you go. You can see the curve increase, decrease. You see the first peak, and then here we are today. You can see that second wave rolling on through. Last month and a half has been garbage in our county. And I don't really know. I don't know the rest of the country. I haven't really been following the rest of the country. I'm just overwhelmed with all the other stuff. So I really just focus on our area because I'm not traveling anytime soon. My brother and sister live in Florida. And to the start of the COVID crisis, they didn't really want to make a big deal about the COVID down in Florida. So they had a person that did all the data entry for the entire state. She was responsible for all the data entry, and she didn't skew the numbers. She didn't mess up the numbers because they wanted her to get basically society rolling again. So early on in that, they fired her supposedly because she wouldn't fake the numbers to get everybody nervous. So I don't know. I trust our data. I trust that maybe they could be skewed, but I doubt it. Maybe. Anyways, here we go. The last week or so. Here's the 6th. I think that's Sunday. Yeah, that's Sunday. Sunday and Saturday's data. So Sunday, last time we had numbers up, it was 125. Saturday was 172. If you go back to the last Saturday and Sunday, so the 28th and 29th, here's the 28th, 29th. 28th, 29th. Again, the 28th, 29th, the labs aren't really pumping out too many COVID testing. And Monday, Tuesday, Wednesday, Thursday, Friday, you see this curve increase again. So again, you're seeing that spike throughout the week, Monday through Friday. You're seeing that increase and then decrease on the weekends. What's going to happen today is going to be probably Monday's data, Tuesday's data. I'm guessing you'll see a curve very similar to 1, 2, 3, 4, 5. Hopefully not this high, but that would be my hypothesis on analyzing all this data. Just be safe. You guys gotta still live your life a little bit. Still have to go shopping, but just know if you go to Walmart, if you go Hannaford, wherever you may go, that there's probably COVID in that store, and you just want to be safe. Definitely wear the mask over your nose correctly. I don't have a mask in front of me. Wear a good mask. What I did when I went to Walmart yesterday, I doubled up just to be safe. And then when I get in the car, when I walk in the store, I sanitize the car. But think about that for a second. You touch that little sanitizer in the spray bottles now. Think of how many people touch that spray bottle before they wash their hands, before they don't wash their hands. So that bottle, it's going to be disgusting. So after you touch that bottle, make sure you sanitize again. Wipe down your cart. It doesn't hurt to sanitize, or use some bacterial spray again, whatever. So I go through the store, shop, get my things, wear my mask right, and then as soon as I get to the car, my groceries in, whatever, shut the door, I just get some sanitizer and just wipe up pretty good, take my mask off. I feel better. And then I'm really a freak. My family's a freak. We get home. As soon as we get home, well, I go shop myself. But anytime we go out, as soon as we get home, I shower just to be really safe. But, it's a little excessive, I think. But makes me feel better about things. All right, so the COVID is definitely out there. Be safe. I know I went for a few minutes on that today. Our update for today, our agenda for today's class. Here we go. Happy Tuesday. Quote of the week comes from Sheryl Sandberg. If you're offered a seat on a rocket ship, don't ask what seat. Just get on. Get an opportunity, take advantage of it. All right, daily agenda for today, Tuesday, December 8th. It was the 78th earlier. 2020, so day 4. We are going through Unit 5, Chemical Bonding. We're still continuing on with Ionic bonding. We're going through topic 3 today, which is going to be naming and writing ionic formulas. We have guided notes. We have a flick. And then we have an exit pass, which maybe you want to do at the end of tomorrow's class. So please open up your guided notes. There's no warm-up today. Please open your guided notes for unit number 5. And let's see where we left off for class. So a little snapshot where we were, where we're heading now. through this really quickly. Oh, didn't start too long ago. Topic number 1 we went through for ionic bonding was about ion formation. We know what ions are. Ions are going to be either gaining or losing electrons. When they do so, they're going to be just like the nearest noble gas. And when they lose electrons or gain, they're going to have 8 valence electrons, which is a stable octet. We looked at some ions. We figured out the electron configuration and compared them to the nearest noble gas. We talked about positive ions, were metals on the periodic table. When there's only one charge listed to the ion, then it's easy to identify and name that ion. One charge listed, it's the name of the element. For example, group 1, group 2, one charge listed, it's the name of the element. So that's the one charge that I'm dealing with right there. One charge listed, name of the element. When there's more than one charge in the situation, what's going to happen is you're going to name the element, and then you're going to put Roman numerals to indicate which one you're dealing with. So more than one charge listed, it's going to be the name of the element, and then the Roman numeral that corresponds to whatever one you're dealing with. For example, it looks like group number 7 has every element in that group as more than one charge. So if you're identifying any of those elements, then you have to put the Roman numerals to indicate which one it is. Hopefully you understand that, because that's going to make sense for today's and help you out for today's class too. All right, scrolling on down, negative ions, super simple. All you do is identify where the negative ion is, non-metal. So whatever non-metal it is, all you're going to do is just put the first syllable and you're going to add "ide." First syllable and add "ide." So these guys over here, kind of, are my non-metals. So nitride, carbide, oxide, fluoride. Take the first syllable. Fluorine, fluoride. Chlorine, chloride. Bromine, bromide. And add "ide." It's a lot easier. No Roman numerals are attached to that. Chemical bonding. We talked about 2 different types of bond. One's going to be sharing electrons. One's going to transfer the electrons. We have been analyzing transferring electrons, which is ionic bonding, a lot. We talked about a bond forming. 2 atoms come together to form a bond. They hit, so they collide. Upon collision, there's going to be some friction happening, heating on up. As those things collide, heat up, then energy is going to be released. No, that's exothermic. No, that breaking a bond is going to be endothermic. We talked about ionic bonds, a metal and a non-metal. Transferring electrons. When Na has 1 electron, it transfers on over, gives it off. Na is going to form a positive charge because electrons are negative, and Cl is going to form a negative charge. We talked about covalent bonds briefly. We'll talk about that a little bit more. It's 2 non-metals. They share electrons. And ionic bonds, metals lose electrons, form positive ions, oxidation. We talked about this phrase, Leo says grrr. Loss of electrons is oxidation. The gain of electrons is reduction. We drew atoms and we drew ions. We named the ions as well. We talked about ionic bonds and change in electronegativity greater than 1.7. If it's greater than 1.7, it's an ionic bond. It also has to be a metal and a non-metal. We talked about forming formulas, chemical formulas with 2 elements. 2, a metal and non-metal. You crisscross those charges and you got the formula. We talked about properties. We talked about binary compounds, and that's about, we did quite a bit. We talked about binary compounds, which is 2 elements bonded together. It's the positive charge followed by a negative charge. We did a chemical formula again. More about binary compounds. And then we got to naming. That's where we finished up last time in class for my record. Hopefully we're on the same page. So potassium chloride, positive ion, followed by negative ion. Again, if there's Roman numerals, that means there's more than 1 charge for the metal. Hopefully that's all familiar in your minds, your brains there. Now we're on to writing formulas, giving the name. So in this situation, it's a binary compound, which means there's 2 elements that are transferring electrons ionically. So 2 ions bonding together, ionic bonds. And you have 2 names there instead. So here we go. How to write the formula, verify the charges on the periodic table. So the first thing I would do in this situation, so I'll do like the first 3, and then I'll have you guys like help me out with this to make it more interactive. What I'm gonna do, I'm just gonna highlight those cells, just so it pops out at you guys a little bit more. And I'm gonna center it too, and bold it. So the first element we have is potassium. Hopefully you know what potassium is by now, but if you don't, you forgot what potassium is, you can go to page 1011 really quick. I'm not gonna do this for all of them, but you can find potassium on the reference table, and there it is, element number 19. Potassium is K. So you have a K, a big K. The charge of K is in group number 1. Potassium is in group number 1, has a charge of +1. I know I should probably zoom in on that for you guys. All right, so K has a charge of +1. What I'm going to do over here to the notes, put K with a +1. So that's going to be control period +1. So these subscript and superscripts are super annoying. Super, sub, I don't know. They're not really that annoying, but it's a lot of, I don't know, functions on the keypad. So control period brings it on up. Control period brings it on down. Now you're dealing with sulfide. Sulfide. So sulfide is going to be the other element you're dealing with, S. Let's check out sulfur. There's sulfur. Sulfide is sulfur. The first charge listed there is going to be the charge that you're representing with. So S minus 2. So S, and then minus 2. So it's got to be a positive and negative. So this is going to be a -2. Control period, -2. Lastly, what you're going to do, you're going to write the formula. How do you do the formula? We did it before. All you're going to do is going to crisscross those charges. So crisscross those charges. I guess I'll do it for one. Or maybe I'll just zoom in on one of them. And then just mark it up. So crisscross your charges. That one carries on down to here. That -2 turns to a +2, carries down to here. It's going to turn into a subscript value. So it's going to be K. And then it's going to be K control comma brings it on down to 2. S1. You could leave it like that. Or you could just say, oh, it's just K2S. That's a little bit more appropriate. K2S. The next one is cobalt 2 oxide. From the name, we're going to come up with a formula. So cobalt is CO. The charge on cobalt is going to be given to you right there. It tells you it's going to have to be +2, +2. And then oxide is O. If you don't know what oxygen charge is, you definitely will know it very soon. Oxygen charge is going to be a -2. So O -2. And you're going to crisscross those charges. So crisscross those charges, we should get an answer of CO2O2. So I'm going to give you guys about 5 minutes to try the rest of these out. I will be back. There's someone at my door that's here for moving that I have to talk to really quick. So I'm giving you about 5 minutes to do it. I'll be right back. I can't talk to you if you need help, but please try those out. Okay, sorry about that, folks. Hopefully I had a chance to go through a few examples. If I'm breathing heavy, just out of shape and ran. All right, please go through. Give me the best answer you got for the first one, please. What's the formula for cobalt-3 oxide? I'm going right down my order. Please tell me what you got for an answer. Type it or unmute. Alan first. Please tell me the formula.
CO +3 and then O -2. And then the formula would be CO2O3.
CO2O3. Thank you very much. CO2O3. Okay, correct. Thank you. Next one up, we have tin 2 sulfide. Seam, welcome back. How you doing?
I'm doing good. How are you?
Not too bad. What's the formula, please, for this one?
Would it be SN2 and S2?
SN2, S2.
S2.
All right. It is SN2, S2. If I can get that in there. But you could simplify that. It's not working. Oh, you kept less. Could you simplify that or no?
Well,
there a comment?
Just SN.
Yeah, it's just SNS. SNS. So if there's a common term there, what's that? Typo 2. If there's a common term, they could divide them by both of them. So 2 is a common term in both these. So we divide 2 by both of them. We get SNS. Thank you, Asim. Next up, Bellman. Welcome to the party. Tin 4 sulfide. What is the formula for that? If you don't know how to do it, when we get to the lower ones, then we'll do it together.
I'm not sure, actually.
All right. What's the symbol for tin?
Is it? I actually don't know. I know it's not T.
Asim just said, Asim, I'm just going to throw it out here. Asim just did tin 2 sulfide. You have to do tin 4
SN?
sulfide. There you go. SN. If you don't know it, though, we can check out page 10, 11, pine up here. But I'm not going to spend that much time on that right now. So SN, let's rewind and pretend, I'm guessing you didn't do this one yet. So let's do SN. What's the charge of SN? It comes from this. Let's find a C. So that is a Roman numeral. Where'd you go, Bauman? You left me? We'll do this together. It's all right. You know that Roman numeral or no?
That's 4.
That's 4. So that's going to be SN plus 4. What's sulfide? What symbol sulfide going to be? Sulfur, sulfur, sulfide. So it's going to be capital S. So sulfide's that. Let's check out the charge on sulfur just to make sure. Sulfur. There it is, sulfur. It has to be negative, so it's got to be -2 for the charge. So it's going to be -2. S -2. Crisscross those charges. What's my formula going to be?
SN2 and then S4.
Yeah, SN2, S4. Could you simplify that?
Yeah. It would be SN and then S2.
SN, S2. Thank you. Calcium phosphide. Calcium phosphide. Next one up. Emma, calcium phosphide, please. Please put in the chat, or you could unmute. We could talk.
I think she said she's having internet problems again.
Oh, okay. Get that hot spot. Thanks, Faith. Irvin, your time to shine. Irvin, we have calcium phosphide. Calcium phosphide.
Wouldn't it be Ca +1 and then P minus 3.
All right, Ca plus 1. You could do it just like that. And what was the second part you said?
P minus 3.
P minus 3.
So it would be Ca3 and then P1, or Ca and then Ca3 or P and P.
Okay, good. Ca3 P. P's minus 3, right? Okay, good. Calcium, you said plus 1? Let me just check that out quick. Let's just check that in the reference table. Calcium's in group number 2. So that's a little.
Oh, plus 2, I mean.
Plus 2. So it's got to be plus 2. That's the only thing there. So it's plus 2. So when you crisscrossed it, we should have got a subscript for phosphorus of 2. Aluminum bromide. Next one on up. Faith, you're up. Aluminum bromide. If you got the formula, I'll just take the formula. If not, then we'll do it together.
I have AlBr3.
AlBr3, correct. Al. I like to put the space in between just so you know the difference, but you don't need to. AlBr3. So you could have figured out the crisscross rule on that one. Thanks, Faith. And last up, Frank. Silver nitride.
Hey, Mr. Brown.
What's up, Frank? How you doing?
Doing all right. Doing all right.
Yeah? You feeling
Yeah,
okay?
just looking out for silver.
Oh, yeah? Silver?
Mhm.
Silver and gold. AG. AG, it's a transition metal.
Transition metal. Oh, okay.
Element 47.
Could you happen to tell me which one it is?
47.
So do you know where silver is on the reference table?
Element number 47.
47. Thank you. So it's gonna be AG.
Yeah, AG. Did you do the formula? You didn't do the formula yet, right?
No, I did not do the formula.
All right, so let's do AG. Charge.
Plus 2.
You see my screen?
Oh, plus 1.
Plus
my
1.
bad.
I know it might be small on your screen because you got your paper there too. Plus 1. And nitride. What's nitride? Nitrogen. Nitride.
Oh, nitrogen.
Nitrogen.
Oh, it's gonna be nitrogen. It's gonna be plus 2.
And so it's gonna be N, right? Nitrogen.
Yeah, N. Yeah.
And ionic bonds are gonna have a positive charge followed by a negative charge.
Negative.
So this is positive. This has to be a negative. So it's gonna be negative something. Let's just check it out. It's the first one listed is gonna be the one that we're dealing with. So right now it's only the first charge listed, so it's gotta be -3.
Yeah.
So pop it on in, crisscross those charges, and we get a formula of
AG3 and N. Just N.
Yeah, and you can say N1, N's better. Thanks, Frank. All right, so those are binary compounds. You could name a binary compound with 2 different ions. What's going to happen now is we're going to get to a little bit more complex, similar, but a little bit more complex type of bonding called ternary compound. So a ternary compound is going to be more than 2 elements. So it's going to be several, maybe 3, maybe 4, maybe 5 elements bonding together. Ternary compounds, before I jump into that, I'm going to start off with a YouTube video naming compounds.
We'll cover plenty of examples going from the compound name to the chemical formula and from the chemical formula to the compound name, because naming compounds doesn't have to be complicated. Hello everyone, I'm Melissa Maribel, your personal tutor, and before we get to the examples, here are 3 things you really need to know for naming compounds with polyatomic ions. Important thing 1, to name an ionic compound with a polyatomic ion, the name will consist of the name of the metal followed by the name of the polyatomic ion, and everything is in lowercase. Important thing 2, when finding the chemical formula from the compound name, we will always have to balance out the charges for ionic compounds. And these are the charges you will need to have memorized. So if you have to pause the video and write these down, please do so. Important thing 3, Now, polyatomic ions, polyatomic meaning it's composed of 2 or more atoms, and ion meaning it has an overall charge. Here's a list of common polyatomic ions you will need to know, and your teacher should also provide you with a list. Now you're ready for the 3 examples, plus at the end I'll teach you a trick on how to memorize the polyatomic ions even faster. Example 1, same charges. We are given the compound name of magnesium carbonate and asked to find the chemical formula. So let's first identify the symbol for magnesium and its charge. Magnesium has a charge of 2+. Next, we'll identify what carbonate is and its charge using our common polyatomic ion table. We'll see that carbonate is CO3 with a 2- charge. Since we have the same charges, there is no need for an additional subscript since our charges are already balanced. So this is our chemical formula. Going from the chemical formula to the compound name, we will identify the name of the metal and the name of the polyatomic ion. This is lithium and this is acetate. The compound name is then lithium acetate. Example 2, different charges. Our given compound name is aluminum sulfate, and we are finding the chemical formula. So identify the symbol and the charge of aluminum, which is Al with a 3+ charge, and sulfate is SO4 with a 2- charge. Since this is an ionic compound, we must balance the charges. To balance the charges, the charge of sulfate now becomes aluminum's new subscript, and the charge of aluminum now becomes the new subscript for sulfate. Note, whenever a polyatomic ion requires a subscript, we will place the entire polyatomic ion in parentheses with the added subscript outside of the parentheses. So this is our chemical formula. Now going from the chemical formula to the compound name, we will identify the name of the metal and the name of the polyatomic ion. Ca is calcium and OH is hydroxide. So our compound name is calcium hydroxide. Example 3. Both are polyatomic ions. Given the compound name of ammonium sulfate, we'll find the chemical formula by identifying each type of polyatomic ion and their charges. Ammonium is NH4 with a 1+ charge, and sulfate is SO4 with a 2- charge. To make the charges the same, the ammonium needs a 2 subscript. So ammonium will be in parentheses with a 2 subscript outside of the parentheses, followed by SO4. And this is our chemical formula. Now going from the chemical formula to the compound name, we will identify each polyatomic ion's name. NH4 is ammonium and NO3 is nitrate. The compound name is then ammonium nitrate. Okay, here's the trick on how to remember all the polyatomic ions faster. Most polyatomic ions end in either -ite or -ate. Notice how the ones ending in -ate have 1 more oxygen than the ones ending in -ite. There's the trick. The 8s have 1 more oxygen than the ites. Now you only have to remember the 8s, so this cuts your memorizing in half. This topic is so important. That's why I videos and I designed a how-to guide on naming compounds and acids that includes over 30 pages of detailed examples and explanations, all to save you time and get it right the first time around. The link to shop my notes is in the description box, along with other helpful resources like homework help and tutoring and so much more. And remember, stay determined. You can do this.
All right, you guys could definitely do this. If you understood that video, you're in awesome shape for this stuff. And ternary compounds. Let's put some basic information down before we proceed. So ternary compounds, again, a little refresher. You could always do your little notes in advance if you'd like to and just do the examples together. It's not a bad idea, and you can listen along as we go through class. So ternary compounds, there they are. All right. Ternary compounds, an ionic compound containing at least one polyatomic ion. And ionic bond. So I'm going to bold it all the time. You know my routine. Cap pocket. Ionic compound containing at least one polyatomic ion. It's really not that hard. It sounds like it's hard, but it's really not. Polyatomic ions, so we're going to be located on page 2 of the reference table. It's an ion made from two or more. Two or more atoms, and you can find on a reference table E. And like she said in the video, if you look them up, you'll notice a few things, a few different traits. They are all made up of one or more atom. That's one thing. The comma thing, made up of one or more atom. More than one atom. Almost all of them, I skipped that one. Almost all of them have a negative charge. Most of them contain an oxygen. The last thing's given to you. So ternary compounds, an ionic compound containing at least one polyatomic ion. It's an ion made up of two or more atoms. It's located at table E, so there's nothing to even memorize here. Use the reference table. Made up of more than one atom. There's a negative charge, and most of them, almost all of them, contain an oxygen. The positive charge ions end in ium, I-U-M, and the negatively charged ones end in ite, or ate. So no more ide. So sulfide, nitride, those correspond with binary compounds. If they have ending like ite or ate, those are going to be proof it's going to be a polyatomic ion. Let's just check them out for a second before I get too much further. So polyatomic ions are located on page 2 of the reference table. I'll go back to the notes in a second. So hopefully you have a reference table handy. Page 2 of the reference table, these are the polyatomic ions. So these polyatomic ions, you can notice a few different factors here, like the endings, ium, or ate, ide, ate. See those endings there. Let's check out some more. So we have more endings like cyanide. That's a tricky one because you think it's sulfide. But you have some ites. You have some eights. You can see that there. But anyways, in this situation, you can see that most of these charges, if you look at the charges there, most of them are a negative charge. So it's going to go second. So besides the first three there, everything else, these guys are negative. All the other elements or compound polyatomic ions are all negative charges. The first three are my positives. Everything else is a negative. So anytime you're dealing with one of these, you definitely want to use a reference table. So I would say if it's something you never heard of, like perchlorate, doesn't sound like an element, or thiosulfate, it's not an element, then like nitride, this is a little confusing. Nitride is one of them. Nitrite is this. Nitrate is NO3. So that is a little confusing there because you have ide, ate, ite, and ate. The endings. Ide, ite, and ate. So you have to differentiate between those really. But we'll practice with those. Let's continue on. All right, so rules for writing ternary compounds now. Some rules. So same as binary, except use parentheses. So there's going to be parentheses surrounding the compound. So again, parentheses. Surround the polyatomic ion. Parentheses surround the polyatomic ion, and a subscript will be used when there's more than one polyatomic ion in the formula. Naming this the polyatomic ion, what happens? The positive charge is listed first, followed by a negative. Positive ion still retains its name, with the stock system used where appropriate. The only positive polyatomic ions, there's a couple of them, you saw them, there's 3 of them. I put 1 on here, but there's 2 more that you should be familiar with. There's ammonium. There's one with mercury. The negative ions will most likely be the polyatomic ion, which retains its name on page 2. So a bunch of gibberish there, but we're going to have to go through and do some examples for that. All right, let's try some out. So writing a ternary compound, very similar to writing a binary compound. First one up is ammonium sulfide. Ammonium sulfide. So ammonium, I'm thinking about this and going through the process. I'm thinking about the reference table, the periodic table, and I never seen this would be my thought process for you. I never seen ammonium on the periodic table of elements, but I have seen sulfide on there. So figure out which one sounds like an element, which one you never heard of. Probably never heard of ammonium. So that's going to be on page 2 of the reference table. Page 2 of the reference table, you can find ammonium. So ammonium, there it is, NH4 positive. Let me scroll on over for some reason. All right, so it's going to be NH4 positive. That's the first thing. So before I get too far into this, I'm going to highlight it all just so I have to keep putting my highlighter on and centering them and bolding them. All right, so NH4 positive. That's the first thing we're going to do. NH4, control comma. And then the charge is going to be positive. So what you're going to do around the polyatomic ion, once you find it, is you're going to put parentheses around the polyatomic ion. So my parentheses go around the polyatomic ion. The charge goes outside of the polyatomic ion. So NH4 positive looks like that. So I wish they just put parentheses around here to make it a little easier for you. You definitely need parentheses around the polyatomic ion. Once that is done, you have sulfide. So ammonium's NH4 positive. Sulfide, just like the binary compounds, it's sulfur. Oops. It's going to be just an S there. Oops, still not there. Just an S. And the charge is going to be on the reference table under the elements. So find sulfur on the periodic table. There's sulfur. And the charge is -2. So control period -2. Once you have that, it's just the same exact thing. You take those two charges and you crisscross those charges. So again, take those two charges. That 2 is going to carry on right there outside the parentheses. And that's a positive. Positive what? Positive 1. That's going to go outside of the sulfur. So in this situation, you're going to have, copy that, and paste it over here. It's going to be similar. So it's going to be NH4 and a subscript 2, and then S1. So that's the chemical formula for it. It has to go outside the parentheses, the subscript for the polyatomic ion. So you can represent like that, or you can say NH4 2S. That's appropriate. Let's try another one. Cobalt 2 cyanide. So cobalt, I know cobalt's an element. Hopefully you do too. Cobalt is CO. That 2, just like the binary compounds, represents the charge of +2. That's all from the past. Cyanide, you're checking out the reference table. You're going through page 10, 11, the reference table. You say, where the heck is cyanide? You go through that process. You're not seeing it. And once you get to that point, you're like, oh, cyanide might be on page 2 of the reference table. So if you check out page 2 of the reference table, you'll see polyatomic ions. And there's my cyanide. So cyanide is going to go inside parentheses. It's going to be a CN. And the charge is going to be -1. Take those two charges and cross them on up. Do a little crossover. Crossover move there. Your formula is going to be similar to that, but you have to crisscross them. So what's going to happen here, again, you're just going to take the charges. You're going to take that 2. It's going to go outside the parentheses to there. That 1 is going to go there. And Joe, no, I'm not going to jump on my desk and start doing my little dance move on crisscross. It's just not the right environment. I have this room here, the Zoom room. You guys can't see your faces still. Still not going to pull out that crisscross dance move. But anyways, cross them on up. It's going to be CO1. Again, you don't have to represent the 1. It kind of looks foolish if you do. But I won't make fun of you. Still going to give you the point in the region. CO1. And then CN2. Cross them on up. Not too bad. Next one on up. Let's see who could help me out now. Alex, your time to shine. You're next up on my list here. We have the compound cobalt 3 sulfates. How you doing, Alex?
I'm doing good.
Good. We have cobalt 3 sulfate. What's the symbol for cobalt?
CO.
It's a charge for cobalt.
+3.
+3. That one's like a binary compound. What's the sulfate we talk about here?
It's one of the polyatomic ions. It's
Definitely. Because if it was I, if it said I, then it's all yours. I'll stop talking.
Okay, so SO4. And then 2 negative.
2 negative, same thing as -2. Perfect. Crisscross those charges, we get a formula of
CO2 and then SO3 or SO4 3.
all right. CO2, SO4, and then that 3 goes outside the parentheses as well. Thank you, Alex.
Yeah.
Nice. Next up on the list, John. Welcome, John.
Hello.
Hey, tin for night. Let's change that to night. I'm gonna change that up a little bit though, so don't get too far ahead of me. 10 for nitrate. I'm gonna switch it up to 8, not ide, because that was a binary compound. ATE. So I'm gonna change that to 8. What's 10 symbol?
SM.
Thank you. Charge?
4.
Plus 4. And what the heck's nitrate?
Is it nitrogen?
If it was ide, if it said ide, it would be nitrogen. Now it's 8. So you need page 2 of the reference table. See my screen?
Oh, sorry. I was looking at mine. Sorry.
It's okay. So you would have found it. But I highlighted it there too. Nitrate would be just NO3. NO3. Charge is going to be a -1. What's the formula?
Isn't it SN3 or SN1?
Okay.
And NO3 and 4.
Good. NO3, 4. Okay, please take about 5 minutes to try to do the next 3 examples. So at 12:45, we'll come back together. So please do the next 3 examples. All right, Joe, you're up. Joseph, welcome back. Hopefully you had a chance to go through his 3. What is the phosphate? What is phosphate, please?
Phosphate, it's gonna be PO going down 4. You can end the parentheses, and then -3.
Omega 3, found that over to the left on page 2, phosphates. My formula, let me just copy and paste this on over, save some time here. So this stuff obviously would be a lot easier if we had a hard piece of paper in front of us, but we'll get through it. What's my formula going to be?
Using your formula, it's gonna be Ca3, PO4, then 2.
Good. So make sure it's outside the parentheses as well. Thank you, Joe. Next up, we have aluminum dichromate. Joey G. Aluminum dichromate. Joseph G. What is dichromate, please?
Dichromate is Cr2O7 or O7 and then -2 on the outside.
All right, so you found on page 2, Cr. Cr2O7. What was the charge on that? I think you might have said it. I'm not sure.
It would be -2.
-2. Okay, I'm going to copy and paste that with the ion charges. Just want to subscript and do all that again. What's my formula going to be?
Al2 and
Okay.
then Cr2O7 to 3.
Third. Good. Thank you very much. So in his situation, what's going to happen here? I'm going to zoom in on that for a second. That 3 outside of the parentheses transfers to 7. And then you multiply those 2 together. So there'd be 21 oxygens. That 3 outside the parentheses also carries over to the chromium of 2. So 3 times 2 would give you 6 of these. It'd give you 21 oxygens. That's supposed to be 6. And that subscript outside the parentheses carries to everything inside the parentheses. That'll be actually like next lesson or 2. So it carries to everything inside. That NH4 carries everything inside. That 2 outside carries everything inside. There's 2 N's, there's 8 H's. The CN, there's 2 C's, and then there's 2 N's. But we'll go through more of that next for a different lesson. Last one here. Jumila, we have silver nitrate. Silver nitrate. What is the correct formula? Or what is nitrate? Let's start with that.
Nitrate is NO3, and then outside is -1.
Good. Nitrate. There it is, NO3, -1. Crisscross, make you wanna, what's the formula, please? When you're ready.
Formula is Ag, and then in parentheses, NO3.
Ag, NO3. Yeah, so she didn't even talk about the 1 because it's already represented by the symbol. That's correct. Thank you very much. All right, so there's silver nitrate. You know, silver nitrate is now AgNO3. So you know if your friends are like DMing you and talking about like different chemical formulas or chemical names, now you could actually know what they're talking about. Like, oh, I can put that together too. I could roll with you guys and figure out what you're talking about. So they throw a snap about like, hey, cobalt-3 sulfate. Throw a Snapchat on that. You could now know what they're talking about. So this is just making you more, I don't know, educated individual. So that's cool stuff right there. Or really on the back of like some foods, your ingredients on, I don't know, some things that you eat, consume, you check out the ingredients on there. If you read something on it and don't know what it is, now you can make it a little bit more relatable to yourself. All right, last thing for today's class, and I'm not sure if we're gonna get through all this, but we'll try pretty hard to. We have a formula, and from a formula, we're coming up with a name. So the first situation, from the formula to the name. So how to determine the name? The first thing I would do is figure out where the polyatomic ion is. So locate the polyatomic ion. I still have it on page 2, pretty large over here, so hopefully you can see it. The polyatomic ion, locate it. Once you locate it, I would put parentheses around it. So the first thing is, once you find it, find K or NO3, one of these. K or NO3, you're searching through it, K, NO3, K, NO3. Oh, there it is, there's NO3. I'm putting parentheses around my polyatomic ion. That's the first thing you want to do. Once you do that, then you're going to put your charge up there as well. So I'm just going to copy and paste this over. Before I do that, I'm just going to switch my screen. So put my highlighter on and center it because I'm weird like that. So there's my KNO3, which didn't work. Why? Didn't work out there. But anyways, we have KNO3. You know the charge of K. If you go to page 1 of the periodic table, the reference table, K is in group number 1. It's going to have a charge of +1. NO3 has a charge of -1. So it's always a positive followed by a negative. And the name of this thing, there's only one charge for potassium. So let's just make sure though. So potassium. Locations in group 1. There it is. Oh, there is one charge. So it's going to be, the name is going to be potassium. There is no Roman numeral because there's one charge. And then NO3, go back to page 2, last scrolling. NO3 is nitrate. Nitrate. Boom. Potassium nitrate. Second example, we have ZnSO4. So go through the same process. Find either Zn or SO4 on page 2. So Zn or SO4. Zn or SO4. Oh, there's SO4. That's my polyatomic ion. So I'm going to put parentheses around that. It's not going to always have parentheses around them. I wish they did, but you got to kind of just find the polyatomic ion. That might be the trickiest part here. You know, it takes a while to do all this stuff with a superscript and subscript. Zn's charge, find the reference table. Flip back to the periodic table. Find Zn. There's Zn. Zn only has one charge. It has to be +2. So Zn charge is +2. SO4, so we're going back to page 2 again. So it'll be a lot of flipping in the reference table. It's going to be. SO4 is sulfate, but its charge is going to be -2. Charge -2. And the name of this is going to be zinc. SO4 is sulfate. Zinc sulfate. Micaiah, next one up, we have FeNO2. What's the charge on Fe?
I'm looking at my periodic table.
No problem.
+2.
+2. So if we look at Fe, Fe has a couple of charges. Why isn't it +3? You are right. Oh.
The first one.
All right. So that's one way you can think about it for now. But that 2, if you do reverse crisscross, then you could definitely figure out which charge is going to be. So this situation, that 2 is going to actually go reverse crisscross, goes back up there. So the charge of Fe that we're dealing with is +2. You're definitely right with that. So +2 NO3. And
Why would it be NO3?
That's it, NO2. Cross it out here and see. NO2. Thank you. NO2. What's my charge on NO2? NO2?
It's a -2.
Up on top. No, that's
-1.
-1. Yeah, no problem. So just a -1. That is confusing. If you had the parentheses there, it'd be a lot easier. What's the name of this compound?
The Fe. It's iron. It's iron.
Iron.
And then nitrite.
Okay. So iron definitely starts off with that. Is there a Roman numeral that's associated with this one?
Is it the 2? Is it iron 2?
Yes, because there's more than one charge. So it's got to be iron 2 nitrites. Good. So the first one there, you guys doing not too bad. Let's try the next one. FeNO2 3. FeNO3 2. Who's up here? Let's go to Kai. Hi Kai, welcome. FeNO3 2. What's my charge on Fe here?
Three.
Yeah, this time it's going to be 3. If you do reverse crisscross, it's going to be a 3. Thank you. Next up is going to be NO3. What's the charge on, I'm sorry, NO2 again. Here we go, is that. NO2. What's the charge on NO2?
-1.
-1 again. So -1. What's my name of this compound here?
Iron 3 nitrite.
Iron Roman number 3. Nitrite again. So the only difference between this and the last one was that Roman numeral. Nitrite. Thanks, Kai. One more example, Leonardo. We'll finish up with your example for today. AgCO3. AgCO3. Talk me through it.
Ag is silver.
All right. So I'll throw silver over here.
And then the charge is 3. No, it's not 3. The charge is 1.
Okay, so I put Ag's charge over here. It's +1. How many charges do we have there?
1.
Just 1 charge. It's good to know for the memory bank. What's CO3?
Carbonate.
CO3 is carbonate. What's the charge on that?
-2.
-2. So you got that information over here. I'm trying to give you a little bit more on your own to do. So carbonates, he's got the charge of -2. Is there a Roman numeral?
No.
Does anyone charge? No Roman numeral. So there is how to go. Thank you very much for your help. So there's a formula to a name. So next time we will wrap up these last 3 examples, and then we'll continue on with types of formulas and formula mass. So I would not do the exit pass. Yeah, I probably put up there later today, but you could do if you wanted to. You did a lot of the binary and the ternary compounds already. So tomorrow's class, we'll finish this up, and then we'll get into some chemical formulas as well. At this point, that's it for today. Thanks for joining, and hopefully you learned something new. Have a great day, and stay safe. See you later, guys. If you have questions, hang up. See you later.
Have a good day.
Thank you. You too. Bye-bye. Thank you, Frank. We'll see you later.
Have a good day.
See you, Irvin. You too. Bye,
Have a good day, Mr. Brown.
Adina. Thank you. You as well. Bye, Joe. Is T doing all right today? Joey? Tristan, you all right? Hey, Ben. Haven't talked to you in a while. Sleeping? Any questions, Tristan? All right, I'll see you. Oh, any questions? I cut you off quick. Okay. Oh, you're sleeping on me. See you later.